Okay, it's a lot of content for half an hour, so I'll try to go as fast as possible to be in the time window I have. Um, so, I'm Saverio Proto from Switch. I work in the infrastructure and data services team. I'll just spend 1 minute talking about Switch and what we do. Switch is the National Research Education Network in Switzerland. We are proud to serve our community with our cloud products and our Switch network. The key point of our cloud is that it's entirely built in Switzerland, so it's regulated by the Swiss law, and we are in very close contact with our community, our users, so everything we do is really focused on our customers that are the higher education, universities, and every organization that makes research in Switzerland. You have to excuse me for my English because in the tentative of learning German, I'm forgetting it, you know, but I'll do my best. Okay, so I said 1 minute, so I should honor my promise. So what's our offer at Switch? Especially what the offer that my team is working on is Switch Engines, is an Openstack cloud for the Swiss universities. So it's what is called a community cloud. We have this new product that we call VPC, is the possibility to have a tunnel from the campus university to the cloud, so that you can run servers on OpenStack and they appear as they are on your campus network. And then we're busy with Scale Up. It's a research project, and in the context of this project, we try to deliver to our user the cutting-edge technology. So we try stuff that is really, really new, and this is also something that we show in this presentation, something really new. So this is a summary slide of what I just said. I better skip it. Here is my nice bio profile. So you guys know me because I've been here already 3 years doing presentations, but I thought maybe I should put this slide on because then there are these nice YouTube videos that stays forever and is for a bigger audience, so people know who I am. So I worked with the National Research Education Network, first in Italy, then in Switzerland, and I have now some experience running production open source products. So with OpenStack, we're proud that we're running a cloud in production for our users completely on open source software. Now, let's go to the hot topic. Today we're talking about Kubernetes. So, first of all, what is it? Because it's something so new that sometimes people don't even grasp like the essential of this tool. It's container orchestration. So when I explain Kubernetes to people that never heard of it, I say, you know, 10 years ago we had VMs, and then we buy a lot of servers, and we have the problem on which server should I run this VM. And now it's exactly the same thing with containers. I have a lot of hardware, and I want to put my application into a container, but who takes care of starting that container exactly on that machine or on another one? And that's Kubernetes, so it's container orchestration. To get started with this technology, you should already know Docker. So Docker is the de facto standard container technology. If you are already familiar with building a Docker container and putting your application into Docker, getting started with Kubernetes will be very easy. And Kubernetes, what will do for me, will manage the life cycle of these containers. So, and now comes the interesting part. Kubernetes on top of OpenStack. So, isn't Kubernetes something like something like complete? Why does it need OpenStack? Well, it doesn't need OpenStack to work, but it's nice when the two things work together. You can run Kubernetes on bare metal, on AWS, on Azure, and of course on OpenStack. And Kubernetes is able to glue together with the underlying cloud to offer you a better experience. So, for example, we can integrate with Keystone so that we don't have to create, again, new users. We can integrate with Cinder so that when I have a container that needs a persistent volume, Openstack is able to provide that volume to Kubernetes on the fly. Then we can set up networking. So the Kubernetes master can talk to the Openstack API and create the necessary load balancers, floating IPs, ports, security groups. And of course, when you talk about networking, you also have a close integration with Neutron. Let's get practical. So there are a lot of links in the slides. You don't have to memorize it, that's impossible, but the slides will be available at a later time, and when you go through them, you can use the links to find all the references. I worked a lot on this Ansible playbook, Kubernetes on OpenStack, that makes possible to easily deploy Kubernetes on top of an OpenStack cluster. There are a few environment variables you have to export. This will create some instances on your OpenStack cloud based on Ubuntu Linux, and will deploy all the necessary packages and will take care of the configuration. So eventually, after running the playbook, you will end up very quickly with a working Kubernetes setup on top of OpenStack. And this is how it will look like. This is a work that started on version 1.7, I think, and I've been developing on it up to version 1.9.4. By default, it starts a Kubernetes master and 3 working nodes. So the master is where the actual control plane is, and the other 3 nodes are where the containers with the applications actually run. You can easily tune these settings and start many more VMs if your setup is bigger. Okay, but I cheated here. I show you Kubernetes get nodes. So the first thing actually would be to configure my client, my computer, to talk with the Kubernetes API. This is how the client configuration looks like. Yeah, it's ugly, but after all, is a lot of redundant text. It's not much information. What's really important is this server with the IP address of the Kubernetes master. So the master has an address, and I want to talk to that API. So that's an important bit. And then you have certificates, both for the server and both for the client down here. So that when you have this file, you just install the kubectl tool on your computer, you can talk to the cluster. Good news, this very complex file is generated automatically by my playbook. So after you run it, you also get the file on your computer to talk to the cluster. So that's how it is. You install the client, you put the file in the special location, and now you are able to talk as an administrator to the cluster. But what about your users? You don't want to share with all of them the admin credentials. So it's nice to integrate into Keystone, and the kubectl client is pretty smart. If you are used to the OpenStack client, you know that the configuration is stored in some special environment variables. They're called OS underscore, like OS username, OS password, and so on. And this kubectl is able to read also those variables and talk to Keystone and ask for a token. So we give some configuration here, and then we have this special user that I created, the OS user at Kubernetes. So the real important bit here is auth provider at OpenStack. That makes possible this exchange. So how does it work? I source my OpenStack credential. I do a Kubernetes command like Kubernetes get pods, and then the client will contact Keystone and will ask for a token. And then I do a request to the Kube API server. In the Kubernetes language, this is called bearer token request, because it has a token in the request. And then the Kube API server is configured with a webhook. A webhook It's just a connection. Usually you can do it on localhost with a component running on the controller that is able to talk the Keystone language. And then at step 4, our webhook, we actually contact Keystone to validate the token. Then we get the response. If the token is valid, and if it's valid, then I'm authenticated, and the webhook gives to the API server all the information about the user and the group he belongs to. So how this webhook looks like. This is what you have to do. You have the Kube API server, and you have to say use an authentication token webhook, and you give this config file. A lot of redundant information. What's really important? The URL where the webhook is running. So we have a program on localhost on port 8443. This program makes the magic of translating the Kubernetes calls to Keystone calls. So where do I get this program? I told you I was giving you the very latest things. This program, you get it here, and it was released 16 hours ago. Not by me, but by Deems, one of the core Kubernetes developers. So this went kind of out of the beta phase, and now is actually published on Docker Hub, this container. So this is something really under development that we are using a switch since a couple of months, but now it's really like getting a shape and going out to production. So it's really with these containers that we publish under Kubernetes Cloud Provider, you can really integrate the Keystone authentication with your Kubernetes cluster. Okay, so now your user is authenticated. Kubernetes can tell for sure that the request comes from a user, and we know who he is and which project he belongs to. Still is not authorized to do anything. So you can use the classical RBAC authorization framework from Kubernetes, and here is a role binding. Again, a lot of text, but which one is the important bit? Here I have a kind group, and when in Kubernetes I refer to this special kind, the group, I mean an Openstack project. So in this YAML, I just say that my Openstack project is authorized to do what? In this example, pod reading. So I don't need to define groups again in Kubernetes. I just use the groups I already have in my Keystone. They're just called projects, and here are called groups. So more integration. I'm done with Keystone. So this part we understood. Nice, kubectl is my client. I reuse my Keystone credentials, and I can log into the Kubernetes cluster and do stuff. Then I have this file, and here is where most of the configuration that make possible the integration between Kubernetes and OpenStack. What do I have? I have a global, so I have some credentials so that the Kubernetes master can talk to the API. I have some settings for Cinder. For example, I explicit that the API version of Cinder should be the version v2. I have a router ID. We'll see later why, because Kubernetes needs to talk with the Neutron router and do some settings on it. And then I have a load balancer section, because Kubernetes is also able to talk to Neutron and create load balancers to expose services. How do I make sure that this file is used by Kubernetes? I do it when I run the controller manager. I just say cloud provider, OpenStack, and cloud config, the file I've just shown. So this will change in the future. When you say cloud provider OpenStack, it will use the OpenStack cloud provider that is internal to the Kubernetes code base. But this is not a very good approach to have the cloud provider code inside the Kubernetes repository, because we support as Kubernetes many cloud providers, and it becomes difficult to have all these people together working on the same code base. So all the specific code for OpenStack will be moved out of this code base. In the future, you will say cloud provider external, and you will run an external manager. But I don't want to confuse you, this will come in the future. At the moment, this configuration works and you can start doing the tests following this example in the slides. Let's talk about now networking. So, Kubernetes networking could be the real nightmare for who starts, because there are so many possibilities, there are so many options. There are all these CNI plugins, and maybe the first day you just don't know which one you have to use. So don't use any. You are already running Openstack. Openstack is already some kind of SDN with Neutron. You can just say network plugin KubeNet instead of CNI. And Kubernetes will start to talk with Neutron and will start to set up the right network you need to run Kubernetes. I have these two ugly links, but the first one shows in the Ansible playbook how I implemented this, and this is very few lines of code. And the second is a very good presentation from Angus Lees in Sydney. He is the original developer of the OpenStack cloud provider for Kubernetes, and he explains in detail how the KubeNet networking works on OpenStack. So here, I have just the time to show you like real quick how it works in a minute or so. You have VMs, or we can call them Kubernetes nodes. Inside the Kubernetes nodes, you have your pods. What happens? How is the networking? Imagine the VM works like a router. Each VM has a network. This network is assigned by the Kubernetes master. So the VM starts, say, hello, I'm a Kubernetes node. Okay, here's your network. And then each pod gets an IP from this network. So two VMs, two different networks. How the east-west traffic works, how a pod can talk to another pod in a different VM. So the pod sends out a packet, and the VM has as default gateway the Neutron router. When the traffic hits the Neutron router, the router has a lot of static routes. It has one route for each pod network, and he knows which one is the VM that should be the next stop for that network. And then the east-west traffic can work this way. Who sets the static route in the Neutron router? That's the Kubernetes master that has a global overview over the network. So what do we have here? We have a layer 3 networks where all the pods can talk to each other. And what's the special about it? We have no tunnels. Everything is done with routing. So we don't need like complex overlay on top of another overlay. This is all, every element in this picture is just a router, and the proper routing is set up by the Kubernetes master talking to the OpenStack API. Just a time check. I should have about 15 minutes, right? Okay. Okay. So the networking, I don't go more in detail with the networking, but you can see the video from Angus Lees. I would like now to touch another very important bit, the persistent storage. So all these containers, they're so nice, they're so ephemeral, they come and go. But what about my data? I don't want my data to come and go, like I need persistent data. How do I do that? So how do I do persistent data in OpenStack when I need the volume? I talk to the Cinder API and I ask for a volume. Let's give for granted that my Cinder API has a backend that is remote, like Ceph RBD, for example. So I'm not talking about local LVM volumes here, but I'm talking about a storage backend that is accessible by every VM. What Kubernetes will do for me? So an easy example is I say, I want to create a persistent volume, and the kind of this volume is Cinder, and please, this is my volume ID, so that's the volume ID in OpenStack. If I do this, then Kubernetes will be aware of the Cinder volume, and it's able to attach it to a container. So it's actually able to start the container on a VM and then attach that volume to the VM that is hosting the container. But this is not very practical. Why? Because my user that is using Kubernetes, maybe he is not aware that Kubernetes is running on top of OpenStack. I don't want to expose the UUID of a Cinder volume. I don't want to mix context. I want the user to speak only the Kubernetes language. So how do? I define a storage class. Let's check. So this is a storage class, and the name is default. You see it there in red color. And we see that the provisioner for this storage class is kubernetes.io/Cinder. Okay. You can give extra parameters. If you have, for example, Cinder working with different volume types, you can also say, yeah, Cinder with type fast, availability zone Nova. You can give more details. But the key thing here is that I'm defining a storage class, I'm calling it default, and I'm telling Kubernetes this storage class is actually Cinder. Then when I create a persistent volume claim, I say, please, I just want a volume claim. I want 30 gigabyte. I want to access it read-write, and the storage class is default again there. So with this indirection, now I'm able to use in my Kubernetes YAML files this persistent volume claim that I called MySQL persistent volume claim, and this will create on the fly a Cinder volume of 30 gigabyte, and then on the fly the volume will be attached to the correct VM where my container is scheduled. And if the VM dies, the container is rescheduled to another VM, this volume is detached and is reattached to the new VM so that it is always available to the Docker container. So this is how you can have persistent storage on a Kubernetes cluster running on OpenStack, creating on-the-fly Cinder volumes. Load balancer. Don't try this at home, I say. So, load balancer v2 is something I recommend to test to understand how it works, and it's very practical for prototyping, because maybe you are trying an application and you want to expose it with a public IP, but I would not go to production with this. There are several things I don't like. It requires both destination NAT and source NAT to work. IPv6, I don't know if it works. It might work, but I don't have this information. And this is a pure layer 4 load balancer. So with the load balancer as a service v2 of OpenStack, you cannot do a TLS termination. So you cannot have that classical setup where the SSL connection is terminated on the load balancer, and then you have HTTP traffic to the backend. So, but what is this? I want to explain it better. This is how the network looks like when you use the Neutron load balancer as a service. So you have the VMs. We know the VMs are running the Docker containers. The VMs exist on an OpenStack project network. There is a router, and that router is the default gateway for my VMs. When I create a load balancer, what do? I put another object on this network, and this object is the load balancer, and the load balancer is actually the floating IP that exposes the service. When the traffic hits the load balancer forwards the traffic to the backend, to the VMs. But because the VMs have as the default gateway the Neutron router, to make the traffic symmetric, it's mandatory that the Neutron load balancer makes a source NAT and a destination NAT. In this way, the IP traffic can flow back out from the load balancer. This is okay, but because the load balancer cannot rewrite HTTP headers, cannot mangle the traffic anyhow, because probably the traffic is also SSL encrypted, at the pod, when the traffic hit the pod, you lost completely the information about the IP address of the original client out of the cloud, because the IP address that you see at the pod is as source address is the address of the load balancer on the project network. So if you're exposing a web application and you need to collect log files of the traffic, this is unpractical. This is not something that you can go out to production with. Okay, so given that we didn't like this solution, we had to go another way, and many people in the a lot of people have this problem, of course, anyone that exposes a web application on Kubernetes, and the solution developed was the Kubernetes Nginx Ingress. What's that? So here the key idea is that instead of having a load balancer provided by the cloud provider, you have a load balancer provided by Kubernetes, and the load balancer this time is not just a layer 4 NAT, the NAT, but is a Nginx process that is able to do SSL termination and is able also to do some rewriting of HTTP headers and everything that is necessary. Here you have some reference, but let's explain this in the detail. We have a VM that is called the Kubernetes Master. I said that before. And this VM has also a public IPv4 and a public IPv6, and is where usually I access my API services. So what do I do? In this VM, I run the special Kubernetes Nginx Ingress. It's a Docker container, but is special, has privileges to run in the default network namespace. So it means this Docker container sees the actual network interfaces from the VM. So this means that he sees the interface to the outside with the public IPv4 and IPv6, and he sees the interfaces to the backend where the other VMs are. So running Nginx here, I'm able to forward the traffic back to the pods. Even if I also need a NAT, this is a full Nginx process. So I can write in the HTTP headers the original IP from the client that is accessing the service. So how do I use this? Again, looks very complicated, but it's not. This is an example from the Nginx Ingress that is serving our Openstack Horizon. We see that we have some annotations that are specific to Nginx. We allow Nginx to have a proxy body size of 30 GB. You say, isn't that big? Well, if you want to upload a glance image through Horizon, you need at least 30 GB, otherwise it will not work. And then you have a rewrite, because every request is rewritten with the /horizon as the base URL. And then what do we have here? We have the SSL termination. So you have a TLS, you say that this is the host name, and this is a secret name, and this Horizon secret is a secret I define in Kubernetes, and all this and has all the TLS certificate and key to terminate the connections. So, how I'm done with this Nginx Ingress. I have good news. The content of the presentation is finished. You can relax now. Sorry, it was a lot of content and I had to go very fast, but last bit is how can I get involved? So I like the presentation. These 30 minutes were very chaotic with a lot of information altogether. How can I get involved? The best is to join this Slack channel in the special interest group Openstack for Kubernetes. Is very active. You have people in different time zones, but most are in the US. I would say is more active in the afternoon here in Europe. Also, we have a cloud blog at Switch where I use when I do something that is more or less finished, then I wrap things together and I write some articles here. So a lot of these things that I have shown in the presentation are also on the blog. You can check it out. And this is my email. You can always send me an email if you have a question on this presentation on the integration of Kubernetes and OpenStack. So I hope I'm in the time. And if you have questions, I don't know if we have time for a question. Yeah. So the way I suggest is this architecture where the Kubernetes master has a floating IP that is reachable from the outside, and there is this Nginx container running on the master, and this container is accessible with a floating IP from the outside. When you from the outside connect to this is a reverse proxy, and it will forward the connection to the pods that are running in the VMs. That's the way I suggest to expose the services instead of the load balancer. So it's using these Kubernetes Ingress components, and you define them. On top you have the second line kind Ingress. And you have two flavors, the Nginx Ingress and the HA proxy Ingress. But I tested only the Nginx. I expect the HA proxy Ingress to work as well. So I understand. The question is how do I make proper isolation in networking for pods that belong to different projects? With this solution, I don't support this feature. So we have the Openstack project network, and each pod gets an IP on this network, and it's totally open. So each pod can talk to any other pod, even if you create different namespaces, and the pods are in different namespaces, the networking is flat. But this is a solution to get quickly started. You have different options. You can implement security groups for the pods, but there the integration with OpenStack, I'm not aware of the situation, if it works or not. Or you can drop this network architecture and use another networking plugin that uses an overlay and makes also this multi-tenant separation, so where each namespace has a reserved network. But with this solution I presented here, is pretty much flat. So this is meant for a single user that has full control over his OpenStack project and wants to deploy Kubernetes on top of his project. So if you have multiple users, I still suggest that each user has a different OpenStack project and a different Kubernetes cluster. So I don't want to take you more time, because I know the coffee is ready, and I will be here today and tomorrow, so you can get in touch with me if you have more questions. Thank you very much.